Next up, Jim Galvin from Afilias is going to tell us why implement DNSSEC. One note, when you come to the mic, if you would state your name and your affiliation for the folks on the webcast, we'd appreciate it. Thanks. There's a remote. You got to kind of stay close to the mic.
Thank you. Why DNSSEC? So I know what you're thinking. DNSSEC, what's that? Didn't that die yet? Well, to borrow a phrase from Monty Python's Spamalot, the not yet dead Fred, no, it's not dead yet, as much as many people might like it to be. DNSSEC has been around a long time. We heard a lot about IPv6 this morning and different discussions about, where's the deployment of that and why aren't we along? And DNSSEC suffers from the same kind of scenario. I've been involved in DNSSEC probably longer than anybody in this room. I was there at the table when DNSSEC was first created more than 20 years ago. I was chair of that working group for the 8 years of its life. It was my team that developed the first public domain implementation of DNSSEC back in the day, before the DNSSEC specifications and all that work moved to the DNS extensions working group in the IETF. And Afilias, as a significant provider of registry services, has been committed to DNSSEC for over 5 years now itself. We weren't the first to sign a TLD, but we were the largest, having deployed DNSSEC in .org in 2009. We found the bug in EPP for DNSSEC provisioning that we had to fix and get the standard upgraded so that we could deploy signed delegations. And of course, shortly after that, the root was signed and other CTTLDs have been following suit. And of course, now we have the new GTLD program where all of the new GTLDs are required to sign their zones. And since we now have, a couple of hundred of those deployed and hundreds more on the way, we have quite an opportunity for provisioning signed zones and DNSSEC. So I want to talk a little bit, this is about trying to promote DNSSEC from a different point of view, from a different perspective. This is a little bit of a thought-provoking exercise. I don't really want to talk about DNSSEC basics per se, but there are 3 things that I want to call out about DNS and DNSSEC that I want to use to talk about the value of DNSSEC and then hopefully, motivate its future with you. Most of the people in here are network operators, so you have a significant role to play. You are the next step in the deployment of DNSSEC. This is your opportunity to close the loop and to make it work for the community at large. That's where the last gap is in trying to make this an option for something that we can do going forward. So quickly, what is DNSSEC? And going back to first principles, right? DNS is simply an assertion that a particular data element is bound to a domain name. And more importantly, DNSSEC assures us and provides us an opportunity to validate that assertion. And carrying forward the important characteristic of DNS, you can do that regardless of the source of that assertion. So wherever it is that I learn that this IP address most commonly belongs to this domain name, I can confirm that I've got the right one, and that's what I can use. What's really important to take away from all of this is that in today's internet, certainly not the internet that we knew of or even thought of at the day that DNSSEC was created, DNS is a critical infrastructure protocol. So DNSSEC is a critical infrastructure protocol, much the same way that IPv6 is, although for different reasons. And it has a unique characteristic. It is hierarchical in its deployment, and so it has distributed responsibility. And in fact, that's a key reason why this is important for you. You are an integral part of that distributed responsibility. You are closing the loop. Your participation in deploying DNSSEC and iterative resolvers in particular closes the loop on the ability to use DNSSEC and in order for more people to want to sign their domains. But we'll get to that as we go along here. This is just a quick look at what that infrastructure looks like for DNS. DNS is an infrastructure protocol. DNSSEC is a critical infrastructure protocol. This picture should look completely ordinary to you. where all the players obviously lay out in this picture. What's important to call out here is that iterative resolver down at the bottom center. You are that iterative resolver. You are the network operator that provides that. First principle in security is always to bring security as close to the end user as possible. So even back in the early days, we always talked about DNSSEC being brought to the stub resolver. You know, the clients, the applications would all be doing DNSSEC. But as you realize in the internet today, I mean, the world has changed in 20 years. The need to solve that last mile problem is not as dominant as it was, as we thought it might be back in that day. I mean, you're all network operators. I suspect most of you would believe that, at least within your networks, your users are safe from each other. And to the extent that they're not and something develops, you fix it and you take care of it. Okay? So the important point here is that ingress-egress point in and out of that iterative resolver. That's your opportunity to provide that security to the internet community. You are the only path for them to get that. Okay? You can change the safety and the security of the internet in a dramatic way by providing an iterative resolver for your customers. Okay? And that ability. To the extent that you bundle services, there are additional things that you'll want to get into, but that's an important thing to do for the rest of the internet community. What does that infrastructure look like, and who are all the players? Well, you have the provisioning system at the top, right? The domain registration system. That system is actually really mature right now. Deployment is growing, although admittedly, like IPv6, if one were to look at numbers, the statistics still look pretty bad. But strictly speaking, I mean, my employer, Afilias, we're a registry service provider. So we've done our part. We've been on the leading edge of all of this for, since 2008. Registrars are now in the ICANN community. You have the new registries are mandated to sign their zones. Registrars are actually required to provide support for DNSSEC if the registry requires it. And registries are growing in that regard. You're getting more and more registries that have to support it, and more of them are beginning to require it. So the registrants, the last piece of this puzzle, those who actually own the domain names, the opportunity for them to provision signed domains is there. And that is mature technology, and it's available to them. The next part down is the domain name system itself. And this is where the critical role that you play. In order for signed domains to make sense, you have to validate. Okay? You have the domain name system here with the root system, and the registries are providing the information. They're providing those services. Other authoritative servers, okay, can also provide services. All the modern DNS service provider, software does support DNSSEC data elements. So all of that's there. So the last piece at the bottom is the community, and that's where the role that you play. It's about providing the opportunity to take advantage of DNSSEC services and the security that it can provide. You need those iterative resolvers checking that the domain names and all the data elements in there are valid and growing on that. I have on here that users, maybe not. I mean, yes, users are a part of this community. But in fact, I tend to believe that users sort of expect that everything works. They sort of expect that security is there. If nothing, the horizon that's in front of us, the landscape that we see in front of us, especially in the retail market, is a perfect example of the fact that users just don't have any idea. And there's obviously a lot of examples of companies who don't do their part to provide the protection that they need. So users expect it to be there. They don't know to ask for it. They probably will never know to ask for it. They don't even know what questions to ask to make sure that they have it in any sense. So it isn't clear to me that they're an integral part of the infrastructure. It's up to us as infrastructure providers to ensure that the environment is what they expect and what they would like it to be. So as an infrastructure provider, what is the benefit then? I mean, what happens if you provide DNSSEC? In the early days when DNSSEC was first thought about, we focused on cache poisoning kinds of attacks and those kinds of issues, and otherwise wanting to authenticate the data that was in the DNS. Well, in 20 years, the DNS protocol has long since moved on. There are many ways in which we mitigate cache poisoning attacks. But nonetheless, it's an appropriate thing to want to evolve the internet into a safer, more secure environment. I mean, the horizon in front of us shows us that the internet is under attack all the time, every day. We've seen plenty of presentations today, especially this morning, from an operator's point of view, about DDoS attacks and leveraging the DNS and other kinds of network opportunities. It's a natural evolution in order to want to move that security forward. And more importantly, in the case of the DNS, as a critical infrastructure protocol that virtually everything depends on, you have to provide that building block. You have to provide that cornerstone. So the provisioning system has done its part to make it available, and an opportunity is there. What's needed is to close that loop and to start to provide the validation and make it possible for people to take advantage of this and move forward. And more importantly, to invent things that we haven't even thought of yet. That's the critical part of this, and I'll come back around to that at the very end here. Even today, the question to ask is, without DNSSEC, do I know for sure that I'm visiting the website that I want when I try to follow a link or enter an address or click on something I get out of my search engine? I mean, this is what DNSSEC gives to me. And common people often like to suggest that, well, what if I have, TLS SSL? What if I'm using HTTPS and I have all of that? I mean, haven't I protected the internet and haven't I protected the web? Okay. So the web is an easy example for today, but the reality is all that TLS actually gives you is an encrypted tunnel. It doesn't even really give you authentication. It's certainly not mutual authentication. And the reason why it's a risk still on the authentication side from the web server side is we've seen a number of examples in the recent past of certification authorities, okay, that issue certificates inappropriately for any number of reasons. That they become another gap and another threat and vulnerability in the system as a whole. In fact, even browser vendors, one of the problems that they have even today is they have to maintain their caches of root certificates, because what you have is a mesh of certification authorities. You have hundreds of them, of these root certificates that they have to manage and track in order to validate websites. The DNS has the advantage that it is a single, hierarchical, distributed root, deploying the responsibility for managing this. So it actually eases part of the burden that they have to deal with too, to be able to take advantage of DNSSEC and validating that you've got a website and you've got the right name matched to the right place. So these things cooperate. They complement each other, and you get benefits by combining them and doing both together. So what is it we're trying to build here, and where do we want to get to? We want to get to building trusted domains. We want to get to building an environment, a marketplace, if you will, the opportunity for providers, website providers, service providers of different sorts, okay, to be able to create security services or market the fact that they are better, and this is their advantage and their leverage. So most of you are network operators, and iterative resolver is one fairly straightforward thing to actually deploy and put out there and make available. Comcast in the U.S., all right, the #1 ISP service provider in the United States, is actually deployed, not just deployed by default, validating iterative resolver for all of its customers, but in fact it has documented this whole process and all of its lessons learned and its best practices. So there is plenty of opportunity for new service providers, smaller service providers, to leverage that experience and create a plan for themselves that actually will work. And so that you're not on the bleeding edge anymore. Your risk can be managed. You can see what's going to come at you. And getting back to the TLS example, one of the interesting things about certification authorities, since we had the discussion this morning about name collisions, one of the other risks in TLS is that certification authorities, to date, until recently, when the rules have been changed inside that association of certification authorities, they would issue certificates to single label domain names, which of course creates a conflict with new TLDs. Just as the .prod example was mentioned this morning and all the discussion about name collisions, the whole issue here is about not using fully qualified domain names. And certificates created that risk in the community at large too. So they don't do that anymore, But that allows this opportunity to compare the names and certificates to the name that you get from the DNS. If I now have a secure entry point from the DNS for the IP address that I'm looking for, and I can compare that name, and I know it's a valid name, and it's authenticated, and I can see if that's in the certificate, I have now increased and complemented and enhanced the security that a browser can offer and other services can offer to the community at large. Now, of course, none of this is really, I'm trying, in some sense, I'm probably overstating how easy this might be. I mean, it isn't really. DNSSEC it does require additional expertise. It is more complicated than what we're using today. But what's important to take away from this is that we have fairly mature technology today. That's probably the most important thing to understand. We've been at this for 20 years. I mean, there have been 3 generations of the DNSSEC protocol in those 20 years. There are half a dozen public domain implementations that provide various tools for supporting DNSSEC. We know a lot about how it works. Key management is still kind of an issue. It can be subtle to get all of those timings right, but once again, we have the technology. Most of this can be automated and can be, managed for you, especially if you're willing to do this in software, which for most people as operators, that's probably what you're going to do. Okay. The other thing is, to the extent you provide DNS operational roles, if you're going to do signing, if you're going to do authoritative server hosting, then you do have an extra responsibility. There is still some limited deployment in this space in particular, because there is the issue of, if you are the signer, you have to get the key information, you have to get the public part of the public key information into the provisioning system. Okay. And that's, it's a known step. It's something that has to happen, but it does mean that you need a closer relationship with your customer, because they have a role to play in bringing that to their registrar to make all of that happen. Okay? So the challenges here are not the technology, it's about some of the procedures that we have to look at and the way in which we deploy that technology. And that's the most important point in all of this. One of the comments that people often, or questions that people like to ask about, is the demand for DNSSEC. Where is that demand? Why aren't my customers doing it? Okay, nobody's asking me for it, so why should I implement it? And I think that that's been true for a long time. What this is intended to show is that the balance is kind of level set at the moment. We now have a horizon in front of us, right? We have mature technology. We have a mature provisioning system. We have mature availability of DNSSEC information. We need to close that loop, and we need to provide that validation. And the next step then will be to invent new services and add to that, to innovate and broaden what we can do on the internet in a safe and secure way. And we need DNS to do that. And the tipping point is coming. That's my picture of the horizon that's out there. I think that for years, we've been with the barriers weighing us down and holding us back. But I really do firmly believe that we're past that point. And the opportunity now is to set an environment, to set up the circumstances, to let people move forward and do new and better and interesting things. The way in which we do that and to make that happen is to centralize the complexity. It's not about providing and solving that last mile problem. It's about providing an infrastructure which is safe and secure in and of itself. We should keep it simple for the registrant and the user. So let's not try to solve that problem right now. Let's pull back the solution. Let's pull back the problem that we're trying to solve and just make the infrastructure itself. Provide what the user needs, provide what applications need, what services can take advantage of. Okay. DNSSEC today, in today's market, is more about what you can do with it. It's a critical infrastructure protocol. It's a natural evolution of the environment that's in front of us, the threats that are in front of us, to want to protect that infrastructure and to make it safe and secure and allow the opportunity to build newer and better things. Okay. As a further motivation for the things that you can do with it, and what the opportunity here is pervasive monitoring, of course. We haven't had really any discussion about it here and the UKNOF conference that preceded this, but I'm sure that we're all well aware of that. The world is surveilling and paying attention, monitoring traffic everywhere. Being able to provide greater encryption on the activities is certainly a goal of standards bodies. It was not quite a year ago that the IETF stepped up and created its own mandate to want to improve the security of Internet protocols. We have an RFC 7258 that documents its commitment to this and what it means and what the threat to the Internet that surveillance offers to us and pervasive monitoring. And of course, we have the DANE working group and the DANE protocol down at the bottom, which has been around for a few years and probably has now found a particular solution for itself. One of the things that the DANE protocol provides is the ability to put certificates in the DNS. And going back to the slide I had before about the name that you put in the subject name of a certificate, if you make it a fully qualified domain name, then taking advantage of DANE, you could have self-signed certificates. You don't need certification authorities. You can build on the DNS to have websites that can simply create their own certificate. If you have a signed domain name, you can put your certificate out there, and then it can be downloaded and grabbed, and it's generally available. And you eliminate that burden on the part of browsers and other service providers who are looking to provide services and security services based on certificates. Okay. So, and that's it from me. I can only hope that I have given you something else to think about and a different way to look at DNSSEC. My goal, hopefully, was simply to get you to think about it a little differently and maybe motivate some people to take a step back and think about your business case for supporting DNSSEC in a different way and maybe give you some additional information or a different way to think about it, and hopefully motivate all of that to happen. Any questions? One person runs to the mic.
Yeah, hi Jim, Ray Bellis, Nominate. Jim, you alluded to the subtleties of key rollover. Do you have a view on the argument about whether it's even worth rolling keys? The security community seems sort of two-minded as to the relative duration and use of DNSSEC keys when compared to things like CA keys.
So, if I may, let me separate your question into two parts. You're asking in part a cryptographic question. So, does the cryptography tell me that I need to roll my keys or not, right? If I have a large enough key, in principle, I should not have to change it all that often. And that's a true statement, and cryptographers have been coming around towards that and pressing that sort of model a great deal lately. But the other side of this to keep in mind, from my point of view, is there are two reasons why one would have to roll a key. Okay? One, of course, is in an emergency situation, so something bad has happened. And to that extent, you need to have exercise and have known processes for doing it. So even if the cryptography says that I only have to roll my key every few years, so I can have a long time between, you have to make sure you can still do it. The other situation in which you really do want to roll them is when you change service providers. It's important not to move private key material, and that is also just a standard tenet in security, that you don't move that kind of stuff around, and therefore you have to be able to roll your key in that sort of ordinary circumstance. So key rollers are important. I don't think you can escape them.
Yeah, I mean, the operational practice concern is valid, although the question as to whether that has to be done on real infrastructure or practice infrastructure, I guess, depends on the resource you have available. Yeah, okay, thanks.
Ralph Weber, Nominum, not a question, but two additional comments. So I think the numbers we had for the talk before was that around 5% of the population of the internet is capable of IPv6. And I think Geoff Houston did the same thing with DNSSEC, and the numbers were 10%. So DNSSEC is actually wider deployed than you think. And also for an operator to do stuff, if an operator wants to do IPv6, he has to pretty much touch every network device he has. Whereas if he wants to do DNSSEC, it's just the iterative or recursive resolve that he has to touch. So it's much more low-hanging fruit. So if you want to do that, really do that.
Jeff Houston's number is measuring the amount of DNS traffic that appears to be validating and taking advantage. And actually, I thought the last number was 12%, but yeah, around 10%.
Hi, Jim. Jim Reid from RTFM. Just an observation. The latest versions of Postfix have got DANE support. So in principle, you can now use, with the Postfix mailer, do a DNS lookup to retrieve a certificate, have it validated through DNSSEC, and then you use the results of that to then initiate an encrypted SMTP connection to some other host.
Yes, thank you.
Hi, John Bondykan. You mentioned that we shouldn't really worry about the last mile. However, it seems to me that a lot of the abuse that happens in DNS is the last mile, whether that's captive portals or DNS block lists. So I'm not sure that's a good way to go.
So I was characterizing my not worrying about the last mile in a particular way. Okay, so this is about protecting the end user. And the question is, do I have to protect my end user as my local environment? If I'm an end user and I'm simply using the web and I'm doing things, I'm observing that I probably don't need that last mile path protected for me. I can depend on my ISP in my local environment to give me a recursive validating resolver, and I don't have to worry about that traffic between me and that resolver being damaged in any way and someone trying to hijack my traffic. So I'm safe from other users in my local network or in my ISP's network is the point that I was making. So yeah, obviously long term, security first principle, always bring the security to the user. But I think as a practical matter, we can solve 90% of the world's security problems by not focusing on that last mile. And that's your job here in this room, right? You're all network operators. You protect that last mile, and you'll find the right way to do that as time goes on. I mean, I fully accept that the business case for wanting to deal with that issue is challenging for ISPs. That's your particular high investment with low return at the moment, because you need more DNSSEC traffic to justify all of that. To go back to the iterative resolver thing, I will observe one thing that Comcast did discover. It's important to keep in mind, even especially as a small, local ISP. You do have customer support issues that you have to prepare for and deal with. And Comcast has done a very good job of documenting all of that. So I highlight that for you to think about. It is, in some sense, a simple matter of, just turn it on in your local resolver and all your customers will get it and you'll resolve everything. But, the problem with DNSSEC is, of course, if you're going to validate, then when the validation fails, what do you do? And, of course, you're the first line of defense. Your customers all call you and say, why is it I suddenly can't get to wherever? And, you're not the problem. It's DNSSEC that failed, and you have to deal with that. And Comcast has got their proposal and all kinds of documentation about dealing with that issue. Please.
Neil O'Reilly. I'm concerned about something that seems to me to be a bit of a gap here. On the one hand, I appreciate why you're suggesting that it's important to keep it as simple as possible for users and registrants. But if it's as simple as possible for them, how are they to achieve the leap of trust that they need to make in the service providers who are keeping it simple for them? How do I, a simple registrant, as I am, a simple user, know that the people I'm depending on to keep things simple but trustworthy are doing both of those, simplicity and trustworthiness?
So there are two kinds of users that you mentioned there. There's the registrant user, who are part of the provisioning system, and then there are users who are just simply the web browsers. And one of the things that I observe in all of this is that I think users already expect that the system is secure and trustworthy. Don't think that users, the ordinary web browsing user, has an appreciation of just how bad things really could be, because things seem to generally work. And they don't know the technology anyway, so they wouldn't really know what the right question is to ask. So they wouldn't ask the question, they wouldn't notice. What I think should happen is the application and service providers are the ones that have to upgrade or enhance their user interfaces to provide an appropriate environment for the users. You could argue that browsers already do this today, right? I mean, it's the difference between a green address bar or a blue address bar. Do I have a lock or not have a lock? And they go through, some fairly substantial algorithms, gyrations, jumping through hoops to do the best that they can to provide that best environment that they can for their users. DNSSEC simply becomes another tool in their toolkit to provide that better environment, and maybe they'll come up with another color to suggest that, ooh, you have an even more secure environment now because I've got DNSSEC and I can make that work. DNSSEC also simplifies some things on the part of browsers. It simplifies their certificate management, or it could if we move all of that in a different direction too. So there's opportunities there. From a registrant's point of view, the simplification that I would imagine is that registrars should sign by default. In fact, if you look at the significant successes in certain countries, for when domains are signed, domains get signed when registrars just do them by default, not because the registrant themselves started to ask for it. It simply got incorporated. So if you look at the successes in countries like Bulgaria, and Sweden and even the Netherlands, recently, where that was where the growth was. That's why they have, or the Czech Republic, this is why they have almost 100% penetration of DNSSEC in their TLDs. And why? Because they're signing by default more than anything. That is precisely the reason why it's there. So that's the simplification that needs to come around.
I think we need to go, at least I think the system we're constructing needs to add to what you've described a layer of communication and transparency so that the end user can be convinced of all this good stuff. Because I think it's becoming increasingly clear that it's not safe to take all this good stuff on trust. That's my skepticism.
Yes. I'll just say I share your skepticism, and rather than give a long-winded response, I'll just sort of pause and say we could have a long discussion about all of that. It's all about the market and what it'll do and what it'll bear and how to make it happen. So, okay. Thank you very much.